My name is Kainton Genius, and today we are going to continue with question 2 of our data science question and answer series. And today we are going to be answering one basic but important question in data science. In fact, this is a question that every data scientist should know. Normally, you know that data scientists are involved in writing codes with Python, modeling data, using the Jupyter Notebook and things like that, trying to analyze data. But what ought to be able to explain what actually happens, the various phases of data analysis. And that is something I think every data scientist should be able to know. So let's now look at the 6 phases of data analysis: knowledge acquisition, study design, data collection, quality control, anomaly detection, and data imputation. So let's start with the first one. What is knowledge acquisition? So basically, I've actually explained all of this in my website, so it's there for you to read, but I would like to also highlight some of the important aspects of these phases. Knowledge acquisition is the techniques involved in transformation of knowledge from an existing form to a form which can be used in knowledge-based system. During this phase, rules of transformations are defined. So in knowledge acquisitions, rules are defined, rules of transformation. So basically, you can have data in different forms. It could be some data gathered from the field, tabulated in some form. It could be some data in several spreadsheets. It could be some data gathered in some disk and things like that. So how do you actually transform this knowledge from there's a form where it is to the form that can be used in a knowledge-based system. Meanwhile, a knowledge-based system is a system whereby you can have knowledge information being processed by having an input and then an output phase, more like a system that handles data, that manages transform data and presents data. So maybe I'm going to explain this more in a different question. So what is study design? Study design is also called research design. So it's a procedure and method applied in collecting and analyzing specific variables, the variables specified in a given research, collecting and analyzing the variables. So let's take, for instance, let me just give you an example. For instance, you want to carry out a research on the effect of the wildlife in certain country. You can have variable like number of different species, the population of these different species of animals, the migration trend in these animals. So there are a whole lot of data you can collect about these animals. So these variables is what you actually need to analyze and define in case of study design. So the procedure for collecting this data, will you use a questionnaire? Will you use some custom-made system you've prepared to collect this data and things like that? All right, let's now look at data collection. So this is the simplest one, so I'm not actually going to spend more time. The process of collecting information from various sources. Again, data collection can also be explained or can explain in more detailed way. But basically, you are going out there to the population, taking this sample, and then bringing it back to the lab for you to analyze these samples you collect. Quality control is also called data quality control. It involves improving the quality of data and ensuring that data conforms to the quality requirements. So in this case, we are not talking about trying to make the data look good, but we are talking about there are quality requirements that has been specified for this research. We want to make sure that this data you collected conforms to the quality requirement. It involves procedures such as error detection, duplicate handling, and anomaly detection. So this time you could now see that quality control has anomaly detection to be under it. So in this case, this conforms to quality standards. So quality standards might be different from research to research. So data, okay, so basically this is where we have quality standards. Anomaly detection is a subset of quality control. It's also called outlier detection, noise detection, and other names like that. It is a process involved in identifying items in the data that does not fit into the overall nature of the data. That is, observations that look suspicious or significantly different from the rest of the data. So in this case, maybe I'll just take a simple example to see if I can illustrate this. So let's say you have a data set. Let's try to illustrate it. You have a data set, you have X and Y. It could be several data sets, S1, S2, all the way. You have 10, you have 12, you have 11, you have 16, you have 95, and you have 9, you have 13. And here you have 1, 2, 3, 4, 5, 6, 7. So here you can see that we have 95 to be kind of different from every other data. So for instance, you have 10, 11, 12, 16, 9, 13 may have a mean of 12. But once you add 95, you see that the mean changes drastically. And so it means that this 95 here is likely to be an anomaly or an outlier. So it has to be managed in some way. All right, so we have data imputation simply have to do with replacing the missing data with alternative values. So data imputation does not really mean data entry. That is the challenge that many people might have. So data imputation in data analytics does not mean data entry. It simply means replacing missing values. So we are talking of data imputation. Let's say we have missing values in some place, and you can kind of make up this missing value by taking an average of the value before and after, and you can make it up. So these are the 6 phases of data analytics, and I'd like to stop here. I'll thank you for viewing, and also like to remind you to subscribe to my channel. In the next question, we are now going to explain other concepts in question 3.